Today we will discuss work energy and power, and in it we will discuss work done by a variable force. This is a very important topic. We will try to deal it by using an example. The example is a block of mass m is shifted from the x-axis from x is equal to 0 to x is equal to d by applying a horizontal force F is equal to a plus bx. Find the work done by the force in displacing the block. So here we have this block. The force is applied along the forward direction. Let's call this force as it is given to us. It is F is equal to a plus bx. So at x is equal to 0, the value of this force will be, put x is equal to 0, we will get the value of the force as a, and at x is equal to d, the value of the force we get it as a plus bd. Now, since we want to find the work done by this force, which is a variable force because it is varying with x, we have, let's take another block, or let's draw the same block at some point, say x from this place. This is the block. The position is x is equal to x. Now the force acting on it at this instant will be F. The F is equal to a plus bx. If we put it in vector notation, it is F vector is equal to a plus bx I cap. For a very small displacement of this block, say the block is displaced from this location to this location, this length is dx. So we have this displacement as, or the ds vector as dx I cap. Now writing dw, or the work done for this small displacement by this force, इस फोर्स के कारण एक छोटे से डिस्प्लेसमेंट ds के लिए अगर हम वर्क डन निकालने की कोशिश करें तो यह आएगा f डॉट ds वेक्टर, जिसकी वैल्यू होगी यहाँ पे a प्लस बी एक्स इंटू डी एक्स. नाउ वी वॉन्ट टू फाइंड द नेट वर्क डन. सो नेट वर्क डन w इज गिवन एज इंटीग्रल ऑफ dw from 0 to w, and since it is a variable force, so it becomes a dx plus integral of bx dx. This is a simple integration. For beginners, this should not be a very big problem because it's a very simple integration. बहुत आसान integration होता है ये. The value of x varies from 0 to d. So this work done w becomes, the integral of dx is x, substitute the limit from 0 to d, and the integral of x dx is x square by 2 from 0 to d. Now on substituting the limits we have, it is ad plus b d square by 2. So this is the work done by the variable force in this case. Please remember that whenever we are trying to find the work done by a variable force, we have to take the integration into account. Here the integration which we followed was the integral of x to the power n dx, which is given as x to the power n plus 1 upon n plus 1 plus constant c. Here we have a chain is kept on a rough table with its 2/3 part overhanging from the table. Find the work done by the friction when the chain completely slips off the table. Friction coefficient between chain and table is mu. The length and mass of the chain is capital L and capital M respectively. So now we have, this is the chain which we have. Let's say at some instant when we are watching it, the chain started from x is equal to, the chain started from rest, right? At some instant, let's say that the part of chain which is on the table is, let's take it as x, and the part of chain which has fallen off, its length will be how much? It will be L minus x. So the mass of this x portion of the chain will be given as, let's call it as mx. This will be mass per unit length into x. This will be the mass of the chain which is on the table, which is left on the table, right? Now we have the friction force acting on this block will be given as mu times normal reaction. So let's call this normal reaction as Nx because it is of the x part of the chain. So this becomes mu times normal reaction is mg. So this becomes, the friction force F becomes mu m by L g into x. Now suppose a small portion dx slips off from this table. A small portion dx slips off from this table. Friction will not change significantly. So now we have the work done by this friction force dw will be given as F dot dx, which is equal to minus mu m by L into g into x into dx. Why we are taking it as minus? Because the angle between the force and the displacement, which is theta, is equal to pi. So now to find the total work done W, integrate this work done dW, which is minus mu mg by L into x dx from, see what part of chain was on the table? Since its 2/3 part was overhanging, so the part which is left on the table is L by 3 initially. Okay, so the part which is left on the table is, initially it is L by 3, and final length will be how much on the table? It will be 0. So integrating this, we have minus mu mg by L. The integration of x dx is x square by 2. It will be from L by 3 to 0. So on substituting the values, we have, it is 0 minus mu mg by L, or let's write it as 2L, take 2 outside, into, it is L square by 9. So this becomes, work done W is mu mg L upon 18. So you saw that working with a variable force to find work done is a very simple case. The only thing which you need to remember is you have to make the correct equations. You have to make the correct equations, right? Please remember it. Thank you.